Hello all and welcome to the video on exercise 5e where we're going to look at factorising quadratics by completing the square. And if you hear random bell noises and thudding noises, that's my dog and cat wrestling playing, and they've just been at it this whole time and they won't stop, so I'd have to do the video anyway. Now, factorising by completing the square. I'll go into it more on the next page, but pretty much we use this when the inspection or cross method doesn't work. I'll go more specifics in a second, but just as a quick review, we're going to look at the cross method because that's what we did in the last video, last exercise, 5D. So we draw our cross in underneath this. We need two factors of 12, so I'm going to guess 6x and 2x and 3 and 1. So not that. Oh no, I reckon it's going to be 12x and 1x. 12x. Right, that's not going to work either. Let's see. Hold on. I jumped the gun. It's 4 and 3. 4 and 3. 1 and 3. 3 4s. 4 and 1, 3 and 3, 9 and 4 is 13. Excellent, that'll work. Okay, so 4 times 1 is 4x, 3x times 3 is 9x. We add those together, that's going to give us 13x, and that is the middle term, so that works. So our factorization is 4x plus 3x, 3x plus 1. So that's our factorization. Now, as it says here, we'll look at factorizing trinomials when no factors can be found and when inspection cross method doesn't work, and we can use a process called completing the squares. So to break down exactly what's going on. So we have some trinomial. We have some trinomial, and there's generally two case situations. We have x squared, or we have a x squared where the coefficient is something other than 1. A doesn't equal 1. Okay, in this case a is equal to 1, and our first thing we do if we have x squared, we use inspection. Okay. Otherwise, if we have a coefficient that's not 1, we use the cross method like we just did on the previous page. Now there'll be times when neither of these work. That is generally when the factors are going to be fractions or decimals, or just something that you won't be able to see intuitively, because inspection cross method both relies on intuitive methods, and we're much better at those doing whole number integer problems rather than fractions. So this is where we move on from here, and we're going to introduce this new method called completing the square. Now, completing the square is the same as inspection, where it only works when we have a coefficient of 1 for our squared term. Okay. Now, what we'll get to in a later section is if that we have a coefficient that's not 1 and the cross method doesn't work, we're going to use a method called the quadratic formula. Now, the quadratic formula is always going to work as long as there's an actual solution that exists, and we'll get into that again a little bit later. And the quadratic will work for coefficient isn't 1 or it is 1. It works pretty much in all cases. We don't teach it at the start though, we leave it to the end because it's generally the most involved way, and you'll be much more efficient if you can recognize times when you can use inspection cross method or complete the square, because part of being successful in year 10, year 11, year 12 maths is not only being able to do the maths, to be able to do it effectively, efficiently and quickly. So we try and that's why we give you these other 3 methods, because they're generally more efficient and time is of the essence in tests and exams. So quickly, completing the square, what's it all about? Well, what the goal is we've looked at problems before where if we had, and I can't remember the exact exercise, but we might have had x minus 2 squared minus 4. Okay, now what this really is if we x minus 2 minus 4, we change the 4, we can change this into 2 squared. This is as we have seen in several exercises, okay, we have this something squared take away something squared. We have the difference. Subtraction is a difference of two squares, or difference of perfect squares. I have that exactly here. I have a square and I have a square. This is my A and this is my B in this case. It doesn't matter that the A is a full set of bracket. Okay? It is still something squared take away something squared. It is a difference of perfect squares. Why am I banging on about this? Well, we're going to take quadratics, okay, that don't work for inspection. We're going to take quadratics and we're going to try and turn it into this form. So we might take something, and these numbers, it doesn't matter, I'm just pulling something in my head, okay. We'll have something like this. We're going to try and turn it into x minus or plus, it doesn't really matter, something in a bracket minus, and the key thing is this only works when we get a subtraction, something else here, and it'll be generally it'll be a fraction or some number. And once we get this number here, we can then turn it into a difference of perfect squares by just taking the square root of it and then squaring it. So our goal is to create something that looks like this. Now, it might not always be as neat. It might be x minus 2 minus 3 on 4. And to get this square, we would, like I just said, take square root, put a square there. That's equivalent. Square of a square root is just the number inside. And now I have the difference of perfect squares, and I can use the shortcut of that is equal to a minus b, a plus b. So if I ended up with something that looks like this, I could factorize into x minus 2, then take away the square root of 3 on 4, bracket x minus 2, add square root 3 on 4, and I've just factorized it. Okay, so we're aiming to get something that looks like this difference of perfect squares. So let's get into actually doing it. Now it's a little convoluted, okay, at first, but we will get there. We'll get there. And like all previous sections, every time you first seen it, you're like, oh, what did we just do? There was all these steps, but it'll come with practice and repetition. And so we're going to try and factorize x squared plus 2x minus 2. If you try and do that via inspection, it won't work. You can try, but it won't. Negative 2, the only factors of negative 2 would be either negative 1 times by 2 or negative 2 times by 1. And you add both of those together, you're never going to get positive 2. So it doesn't work via inspection. So we move on to, we go back to our previous slide. This doesn't work, so now we're going to try this one. Inspection didn't work, so we move on to completing the square. Sort of like a flow diagram of where you start. So what we do first is we look at the middle term. The middle term is going to crop up a couple times here. We're going to look at the middle term. Okay? So we're going to halve it and then square it. So, and we're going to look at the coefficient more so. Not the whole term, it's the coefficient in the middle term. So, middle coefficient in this case is equal to 2. So I'm going to halve it. So it goes into 2 over 2, and then I'm going to square it. Okay, and we're always going to do that. That's our first step. So we're going to go 2 over 2 squared. Okay. And in this case, 2 divided by 2 is 1. 1 squared is 1. So we get a 1, but I'm going to leave it in this form through this working so you can get a bit of a hint, at least at the start. Now, what do we do with this special thing, this number we've just made? Okay, we're going to insert it. Okay, we're going to insert it after the second term. Okay, so 2x. I'm going to add this special term that I've made. I'm going to stick it here after the middle term. And because I've added it in, and I'm always going to put the add first, so I'm going to put a little note here in green. Okay. Always the addition of our term first, then subtraction. You'll see we add and then we subtract. Okay. We add the term, then we subtract, because adding 1 minus 1, it cancels out at 0. Okay. It keeps the expression equivalent. Okay. And then our end bit just goes on the end as normal. So we always add our special term first, then subtract it, then our coefficient on the end like normal. Okay, and now we've simplified it. We've got x squared plus 2x plus 1, because this turned into 1. And then we have our subtract 1, subtract 2. Now the beauty of this, making this special term, halving it and then squaring it, we're always going to now get the first 3 terms. That trinomial will always factorize down into a perfect square. It always will. Because we've halved the middle term and then squared it, it'll allow us to always get a perfect square. This trinomial is a perfect square. And if you look at it, if I just write it over here by itself, x plus 2x plus 1, what are the factors of 1? Well, it's just 1 times 1. 1 plus 1 gives me the 2, so it's going to be x plus 1, bracket x 1, and I can write that as x plus squared. So we go from here to here. It's always, this trinomial is always going to turn into a perfect square. The shortcut, okay, because we've got this first, making this special term, we're done with that. There's another shortcut in here. This number here is always just half the middle term. It's always half the middle coefficient. Okay. Because up here the middle coefficient was 2, we halved it, then we squared it. In this case, we're just going to halve it. And this stage you might go, that's all right, we'll go through a couple of examples and we'll get there. Now, we've got a problem where we've got x plus 1 in brackets squared, and then we've got a subtraction. Now this subtraction, it's not a 4 or a 16, that's an easy to get a square. So we take the square root of it and square it, and now I have a difference of perfect squares, and I can use that shortcut, remembering that a squared minus b squared is always going to equal to a minus b bracket a plus b. Okay, and that's what's happening. So there's a couple key points. This one here, we get this special term, special number. We take our middle coefficient, we halve it, and then we square it. In this case, it was 2 over 2, then we square it and we can simplify that to 1. That gives us a trinomial that's always going to a perfect square that turns into this perfect square here factorized. With the subtraction, then we can turn into a difference of perfect squares. So let's do some examples. So first off, okay, we start with the coefficient of the middle term. So I'm going to halve it. Okay, first up. And I'm going to draw some arrows. I'm not going to draw equals because they're not equal. Okay, but just to show the process, I got a 10. I'm going to halve it and then I'm going to square it. So I got 10 on 2 squared. Okay. So 10 on 2 is 5. 5 squared, simplified form is 5. So I have my problem now, x squared, and I'm going to insert. That's a terrible. Okay, x squared plus 10x. Now I'm going to insert it, and I always do this special number. I always do the addition of it first. Add 5, subtract 5. 5 minus 5 is 0, so I haven't actually changed the expression. Plus 3. Now I look at this bit here, and I'm going to leave some space so I can write some notes in. That is going to turn into, and I can put brackets around it. Okay, that is going to turn into x 5 squared. That's 25. Oh my god. Okay, see, even teachers make mistakes. We always learn from them. 10 divided by 5, 10 divided by 2 is 5, but then 5 squared is 25. Minus 25, plus 25 minus 25. That's going to turn into x plus, and I know it's going to be a 5 squared. Now you could figure that out. You can look at this trinomial and think by inspection. I've got x squared plus 10x plus 25. Factors of 25 is 5 and 5. 5 plus 5 is 10. So I get x plus 5, x plus 5. Okay. But this number here, 5, okay, is the middle divided by 2. Okay. Always divided by 2. It's always going to be. That's the beauty of making this number. We know it's always just going to be this perfect square that we're going to create. It's just going to be the middle coefficient divided by 2. And then what am I left with? Well, I've got minus 25 plus 3. Okay. Minus 25 plus 3, that's going to be minus 22. I can write this again as x plus 5 all squared minus square root of 22 all squared. Now I have a difference of subtraction of 2 squares. So I can turn this into, again, I keep writing this because I want to, it comes up all the time, a minus b, a plus b. In this case, x plus 5 is our a, and the square root 22 is our b. So we get x plus 5 minus square root 22, x plus 5 plus square root 22. Okay? Now, sometimes in this case, we might be able to simplify the surd if it's a surd, or if there's a fraction, we can simplify the fraction. But in this case, 22, the only factors are 2 and 11, so they don't simplify the surd. So that's our final solution. So let's do it again. Let's do it again. We start with our 4. Okay, so the 4, what are we going to do to it? We always divide it by 2. So we get 4 on 2. Then what do? We square it. 4 on 2 squared. And if we simplify that, 4 divided by 2 is 2. 2 squared is 4. So my problem, I have x squared plus 4x. I'm going to insert my special number, plus 4 minus 4, always the addition first. Okay, and then what did I have? I had a minus 1 on the end. Okay, so same thing. Okay, this trinomial here, okay, is going to turn into x plus 2 all squared. How do I know it's a 2? It is the middle coefficient divided by 2 will be that term there. Okay, and then I have a minus 4 minus 1, so that's going to be minus 5. I'm going to turn that into x plus 2 all squared minus the square root of 5 all squared. So that gives me, again using my difference of perfect squares, x plus 2 minus the square root of 5, x plus 2 plus the square root of 5. And again, in this case, I cannot simplify the surd any further. There's no fraction to simplify, so that's it. So I hope you're starting to see the pattern of the process. Now, there's going to be times when we do this completing of the square and we get to a point. Okay, so in this case, we've got x plus 2 minus 4x. So just to quickly show you the working out, we have 4 is our special number. We're going to halve it. Then we're going to square it. So that gives us a 4. So we're going to write here plus 4 minus 4. And then we have a plus 7. So if we simplify this, yes, we get this trinomial turns into perfect square, x minus 2 squared. And then negative 4 plus 7 is plus 3. Now the whole point of this process was to get a squared minus b squared. The difference of perfect squares. We've just created an addition. When you get to this point, when there's an addition, okay, we cannot factorize it. That's as far as you can go. That's it. We'll get into what this means later, and you'll actually do most of it in Maths B Advanced when you do your graphing. Okay, but really quickly, a general quadratic looks like this. Okay, and when we've been factorizing, we can let it equal to 0, which will be in a later section. Okay, the special numbers we're getting are our x-intercepts. Now, this quadratic, x squared minus 4x plus 7, turns out it is going to look like this. Okay, where it doesn't cross the x-axis. Doesn't cross the x-axis, that means it's what's called, it has no solutions. We haven't got the solutions yet, but for us it just means it can't be factorized. That's as far as it gets. And that's fine. So if we go back to our original here, if inspection doesn't work and completing the square doesn't work, and we had a coefficient of 1, okay, we get to the point where it can't be factorized. And that's fine. That happens, okay? Not all equations that you're going to come across in life can be factorized. Actually, most of them can't be factorized. Okay. It's just that we pick all the ones that can be to give you for work in the textbooks to build your skills. So, okay. That's pretty much it for the topic. Okay, we're going to have our extension question next up, okay, which is going to involve some fractions. It's going to look a bit nasty at times, but as I said in the last video, part of your learning is learning to not get freaked out by a hard looking question and grind it out. Make an effort, keep going. It looks hard. Oh, it's got fractions in it. Oh no, you're going to, especially if you're going to do year 11 methods, you have to be able to work with fractions and square roots of fractions in your head without a calculator in the very first topic at the start of the year. Okay? So this is a little foreshadowing of that. So by first dividing out the coefficient of x squared, fully factorise 2x squared plus 5x minus 12. Okay? And you're sitting here going, there's no common factor to take out. I can't take 2 out of 5. Well, you can, you just get a fraction as a result, and that's what this is telling you to do, because we can only complete the square when the coefficient is 1. So we have to take out a common factor. So we're going to take it out. We're going to take out the 2. So we're left with x squared plus 5 on 2x minus 6. I almost wrote 12. Okay. Now, this bit here, okay, straight away we've got 5 on 2x. You'll be thinking, I can't do that via inspection. And most of the time you can't. So you'll go straight to completing the square. So we have our 2, I'm going to leave it at the front. I'm going to put a square bracket in here. Okay, so we start with the 5 on 2, that's our middle term. We're going to halve it, so we get 5 on 4, and then we're going to, so we divide by 2. Now we're going to square it, so we get 5 on 4 squared, which we can write in simplified form as 25 on 16. And hopefully you are actually saying, oh, this is yucky fractions. But it is, and that's why I'm saying we just got to grind. We get x squared plus 5 on 2x. Always add our special number first, 25 on 16 minus 25 on 16 minus 6. Okay. So now we have this trinomial. We can simplify, so we get 2 bracket per bracket x. So 5 on 2, half that's going to be 5 on 4, so we get plus 5 on 4 all squared. That takes that out, and now this bit over here, I'm going to do some working out on the side, and don't be afraid to do this, show you working out. We get 25 on 16 minus 6, so 6 times 16, because I want to get this to have a common denominator, and shouldn't be geometry calculator. Imagine this, you're on a test with no calculator allowed at all. 6 is 36 on 3, so we get 96. So that's going to be 25 and 96 to 116, 121, negative 121 on 16. Now, some of you might be noticing these two numbers. This whole problem was created, so it's actually going to end up with something nice for us. 121 on 16. Close that. Okay, so we have a square. At the first, we need to turn this into a square. So we're going to go x plus 5 on 4 all squared minus the square root 121 on 16 all squared. Okay. Now, before we go any further, we can actually simplify this fraction. Square root of 121 plus 5 on 4 all squared minus this turns into square root of 121 is 11 on 4 all squared. And now we get 2 square bracket x plus 5 on 4 minus 11 on 4 bracket x plus 5 on 4 plus 11 on 4. Okay. And now we don't need the square brackets anymore. I put them there in case there's sign issues or something like that, and it's just a good habit to be in. In this case, wasn't To be technically correct, especially writing this line, and this line, you need the square brackets. You just can't leave 2 in front of the first set of brackets. You need the square brackets for it to be equivalent. But then once we get to this stage, we don't need it anymore. So we can just write this as 5 on 4 minus 11 on 4. That will be x minus 6 on 4. Yep, bracket. 5 plus 11, that'll be x plus 16 on 4. So we can write this in final simplified form as 2x minus 3 on 2 bracket x 16 on 4, x plus 4. And there it is, factorized. So it got messy at times. We had large fractions I was having to do multiplication because I don't know my 16 times tables off by heart. So had a crack at that. Okay, wrote out my fractions, got common denominators. We had square roots of what was looking like a nasty fraction, but the numbers were made to simplify down in the end. You're going to have to be pretty confident with your fractions to work through that, but that's how you do it, and it's something you need to get used to. Don't jump for your calculator all the time. I used to do it all the time going through high school, and my mental maths is still terrible. And that's why I was doing 6 times 16, doing the algorithm-based system, so I knew I wouldn't make a mistake in my head. That's it for exercise 5e. That's looking at factorizing by completing the square. Okay. The next section we'll be looking at is using the null factor law. So this whole time we've just been factorizing. You're probably going, what's the point? What's the point? Well, it's so we can end up finding solutions, and that's what we'll start to look at in the next section. If there's been grinding noises this whole time, I apologize. That's my dog eating his bone next to me now. Just won't leave me alone tonight, these recordings. Thank you. Comments, put them on Edmodo. Cheers.